Welcome everyone to the BBSim and Scalability Brigade for February 7, 2020. We have a few topics on the agenda for today's meeting. So let's get started with them. The first thing I've been asked to share, probably everyone already received the invite, but we are going to have a face-to-face meeting in Berlin in April, 27 to 30 are the proposed date. If you haven't, please follow this link in the in the agenda and give your feedback. It will be really great if you can join, so we can all meet together and be productive for a few days. Second point, I wanted to propose a change in the meeting and move it to Thursday. Just a little bit of history. The meeting was set on Fridays because that was the only free day in the week without meetings in the morning. But now that the Thursday meeting, the Thursday Voltha TSD meeting have been suspended, we have a free slot, and we felt like having the meeting on Thursday will work better for people in the European and India time zone, so they can have a social life on Friday night. Does that work for everyone?
Works for me.
Yeah, that's good.
Yeah, good.
Good for us.
Located on the European side.
Sorry, Andrea?
We appreciate that.
Okay, so I'm going to officially move the meeting to Thursday and send out a reminder on the mailing list. Now let's get to the more technical discussion. In the last week, we received a few results from people doing scale tests in different ways and in different shapes. So we thought it was the time to find a way to standardize these tests so that we can compare a result, because everyone is running on a different environment with different settings, and of course it's seeing different results. So it's a little bit hard as now to compare them. I started this document yesterday. It's still pretty rough, but I wanted to quickly go through it just to give an overview and see if there are feedbacks. And then it would be great if we can all iterate over this document and find a common standpoint to collect this scale testing result. So basically, the first thing we need to define for a test is the environment in which we are running, whether that is a physical cluster or a cluster that was brought up with kind, and how many resources are allocated to those clusters. Since the target deployment is on Kubernetes, I think we shouldn't care about runs done on Docker Compose that I know many people use as a development environment. I'm going through the points, but if you have any comment, please feel free to stop me at any point and comment. The second thing that we need to report are some numbers we need, some numbers we have in the system. We need to know how many venues on how many POM ports, how many flows we are expecting to see.
Leo,
Yeah.
just a clarification. When you say PON ports, that PON ports per ONU.
It's the other way around. It's ONU per PON port.
Okay, yeah, sure.
So we need to know the total number of ONUs and how they are distributed on PON ports, because that can potentially lead to different results.
Yeah.
Let's say
Yeah.
if I run with 64 ONUs and I have 8 ONUs on 8 PON ports, I may have different result than running with 64 ONUs on 2 PON ports, and so 32 per PON.
Yeah, yeah, yeah.
In the same way, since we have different workflows that require a different number of flows to be pushed down in the device, I think it will be good to specify what is the number of expected flows in ONOS and of consequence in Voltha. Because anytime we push flow, there is work that is happening in the core to decompose them and to push them down to the devices, and so the load can be different, especially when you scale up to bigger numbers. If you change the flows per ONU from 3 to 6, you're basically doubling the work. And then it would be great if we can collect some information about the configuration we're running with, the version of the containers. For now, I believe most people are running the test on master, but when we formally report the result of a test, it would be great if we can state which version of each component we're running. I will think there is a way, I think all the containers are labeled so we can see the exact version we're running for each component. A very important thing to report is whether we are using a MIB template or not, because that will affect the speed of the OpenONU adapter. And also, what is the delay in the ONU startup, if we're starting all of the news at the same time or if we are sending them up in batches. Another thing that we have seen can affect the system is whether the SEDIS configuration is stored in the net config in ONOS or is coming from an external server. For example, BBSim exposed the SEDIS configuration for all its ONUs, but if ONOS has to fetch that information, may lead to a different result in the system. In the same way, whether we're starting automatically EPOL and DHCP or not can have different results, as well as the logging level in the components, the link discovery, and the periodicity of the flow stats collection and meter stat collection from ONOS. Thing that we'll need to define as a target are the ONU count, so how many ONUs we expect to see, and what is the target operational state and reason field. Because as you know, that changes during the lifetime of an ONU.
I would also add the operational state through the stack. So at the device level in Voltha, the logical device level, and then the actual port operational state in ONOS. Depending on how quickly that's propagated up, might be useful to know. So yeah, port state equals enabled in ONOS is usually, in my testing, a threshold to know when, how far we've made it.
Okay, that's a good point. The other thing we need to always check is that the number of flows is consistent across the stack, and that the state is correctly acknowledged in ONOS. So when we run a test, we need to make sure that all the flows in ONOS are in state added, and there are no flows in pending add or pending remove. And this is
So when it comes to flows, are we looking mostly at flows at the start of, for example, when we just add a subscriber to the system, or are we talking about flows that comes much later, like flows that are relevant to things like IGMP, stuff like that? Or we are just talking like really at the startup of the system, whatever happened on that startup of the system, and then after that is stable.
So that depends on the workflow that you use. So in the AT&T workflow, as soon as a port shows up at ONOS enabled, in the AT&T workflow, ONOS will automatically program an EA-POL flow. Okay. But in others, like Turk Telecom and Deutsche Telekom, there is no EA-POL flow. So there is nothing that happens automatically. As soon as the port becomes enabled, you actually have to add a subscriber to get the VLAN-based flows. In AT&T, we'll have to go through the EA-POL and authentication before you do the add subscriber call. So in principle, when we do these scalability tests, one level of testing scale and performance is to assume ONOS will not send any flows, right? As soon as the ports become enabled. So we want to see the behavior of the system without any flows in the system anywhere, right? Not in ONOS, not in Voltha, not anywhere, right? And then once we have categorized that, then we will add, depending on the workflow, we'll enable flow addition. So in AT&T workflow, it'll automatically get the EA-POL flow. In other workflows, we'll have to do the add subscriber call. We haven't even gotten to the IGMP and multicast stuff yet, right? Because that's still in development. But did that answer your question?
Yes, it does. The only thing I would say, it's there's a process in the core where every time we get a new port added to a logical device, we update a graph that represents the OLTs and the ONUs. This process is quite extensive. Takes it's not that bad, but you'll see a difference when you have a lot of ONUs and added to the system. So it's at startup, it will have a bigger impact. But once startup is done, if you send flows later on, it's an advantage because now your graph, everything set up, is just a question of decomposing. So it's the behavior that you're going to see if you send flows right at the beginning when you're building those graphs compared to send flows later after the system is stable, you'll see a difference there.
Okay, I do believe that Don found something similar. I don't know if he was using flows or not, but he did find that the process of adding a whole bunch of ONUs and ports was probably the most time-consuming part in his tests. And we can talk about that in a second, but let's go through this. Let's go through this document first and see if everyone agrees on how we do the tests and how we report it. And then we can talk about Don's measurements.
Okay, cool. Thanks.
Matthew, performance flag, should we mention it? Like if performance flag will be enabled or not, though it is not yet introduced in the code yet.
Sorry, can you say that again?
In the configuration, should you also mention if the performance flag should be is enabled or not?
What is the performance flag? I haven't heard of this.
Like this, we are going to introduce, like I was in discussion with Matthew, this is Anand here, regarding ticket 910, where we are introducing create traffic scheduler. We thought of introducing one performance flag, which will, under which like all this storing of traffic schedulers and flows will be protected so that it doesn't affect the performance.
Oh, okay, you're talking about the one in BBSim.
Yes.
Okay, yeah, that's another good point.
So right now, BBSim ignores everything regarding schedulers and queues and things like that, but you want to store it for some reason?
Yes, absolutely. We wanted to store it so that tester can verify and validate the flows and schedulers, what has been pushed.
Okay, so you want to add some validation step in BBSim. Okay, so that's normally not required for scale testing, but it's more for functional testing. So I see you want to add a flag. Okay.
Yeah, so the patch is already, I just need to review, but we're very, very close to merge it. But I think I agree with sort of that's more for functional testing to make sure that everything was pushed down correctly. It's probably not needed for the scale test itself, even though I don't think it will affect the performances by much, but it's something that we should verify. Okay, and the last thing I think makes sense to report or to collect as part of the test is the resource consumption and profiling. Both Matt and I have observed that during some operation, the CPU consumption of the core goes up. In some cases, running on kind, you even arrive to a core restart. And so having somehow the ability to map the operation that are going on with the load in the system will be a great thing to know what is happening. And another thing that can happen a lot is what Don was working on last week to add profiling. And I know, Don, you made some changes in the code to enable it. I was wondering if there is value to add it to all the components behind a configuration flag so that anyone can collect this information at any time without changing the code.
Yeah, it'd be pretty trivial to do. It's only like 3 lines to enable it.
So my experience says that every time you use a profiler, the profiler itself affects the scale of the system, right?
Oh,
so scale numbers should never actually. Yeah, so scale numbers when reporting should never be with the profiler on, right? The profiler should only be a debugging mechanism to see, okay, where am I spending most time? But when you're reporting scale numbers, you shouldn't be using the profiler ever.
Yeah, makes sense.
So I guess the question is it worth compiling it in and then hiding it behind a flag and making sure that flag doesn't, if it's not set, doesn't invoke the profiler in any way?
Yeah, I mean, that would be pretty trivial to block that out. And, to that point, though, you would also want a big-ass log message saying, you're running profiler. This should not be, this should not be considered a, whatever, production type code or whatever. Just something that makes it obvious that you're not running in a normal operation mode.
Yeah, good, but I don't know. I think it will be handy to have it as a flag. So if you are seeing some strange behavior in the system, you can just rerun the test that you are doing with the profiler and see what's going on without adding these 3 lines and rebuilding the container and redeploying it. But I'm fine both ways. So moving on, I tried to describe a possible flow for the scale test for the common part of all of the overall workflows that is basically enabling the ONUs. And so the test will have to start with installing Voltha. We're discussing with Sora whether or not we should make the ONOS present optional or not. But if we do, we'll need to report that information. And then I think point number 3 is the most important one, because we need to make sure that everyone is starting the timer to collect the result at the same point in time. The way I've been doing the test was starting a timer and then immediately creating and enabling the OLT and then collecting the result based on that timer. I was doing it that way because the scenario we are most concerned about is an OLT restart or a power cycle of the OLT. So all the news are going to come back together, and this is basically what is going to happen in the system, and that's when we have the time constraint of 10 minutes for 500 ONUs. Does it make sense for everyone?
So about the ONOS being optional, I was arguing against ONOS being optional just because you want to test the whole stack, right? Now you can make programming flows optional, right? But part of the job of activation of an OLT and ONU is that the ports need to be reported to ONOS. If you don't have ONOS, then you're missing out on a on some functionality that is necessary. So it's okay to make it optional to program flows, but I don't think it should be an option to have ONOS in the system, because I think even Matt said that he looks for the enabled ports in ONOS for sort of a completion of the task of activating an OLT and all its ONUs.
Yeah, I was thinking when it came to flows, I tried to work around it by deactivating apps, though for the different workflows, there may be a better way of doing that. So maybe that's really what we should try to do.
Yeah, in the newer versions of ONOS that we are working on right now, you can even disable the EA poll flow. So basically, if you disable that, then everything else is disabled too. And you can also disable, the programming of subscribers with the VLAN flows. So essentially, all flows can be disabled. But I think you still need to have ONOS in there to get the ports. What you were doing is also fine, but yeah.
Yeah,
so that makes sense. Can probably be a setup similar to running the profiler, that you do it if you are investigating a particular issue and you want to reduce the clutter. But when we run a scale test, we should always run with ONOS.
Well, what does initial MIB downloaded mean?
Initial MIB downloaded, what it really means is after the MIB is in sync, the ONU has been discovered and its entries discovered either through the slow sort of MIB upload process or the MIB template process quickly determining it for you. What initial MIB downloads means is that the MIB has been discovered and that the 3 or 4 managed entities needed by all workflows are pushed to the ONU. These managed entities basically are creating of the MAC bridge itself and adding the uni port to the MAC bridge. And I think Gal Ethernet is the other ME. There may be another one in there, but basically it's the basic piece you need to set up bridging.
Okay.
Specifically not tech profile, by the way. Initial MIB download used to mean a whole lot more. Now it's actually lost a lot of weight and it's very bare bones now.
Yeah, okay.
Okay, so I changed the optional install ONOS into always install it and then specifying the OLT app setting. That basically means which flows are pushed. And so then we start the timer, we create an enabled OLT, we wait for all the news to go through the initial MIB setup, and we check how long does that take, and then we make sure that all the ports are reported to ONOS in the correct way. And then if enable equal is true, we make sure that all the news goes into the OMCI flow pushed state. We measure how long it takes, and we wait for all the flows in ONOS to be in added state. Is that something that makes sense to everyone?
So OMCI flows pushed. Does that mean it has the default gem tcon for the OMCI? Because that happens before the MIB downloaded occurs, right?
So the two reason fields that kind of go with that, OMCI flows push simply means that VLAN flows have been pushed. So extended VLAN tagging operation or VLAN tagging operation has been pushed, whether that's for the default VLAN 4091 or subscriber VLAN or the any VLAN. That just means that a VLAN flow has been pushed. As a requirement for OMCI flows pushed to have even happened, tech profile will have already happened. It's just usually one happens right after the other. Tech profile success happens, and then on the heels of that, OMCI flows push happens.
Right, but that may not be at the end of it, I guess, right? I mean, there may be more stuff to come once authentication happens. Right, yeah.
So this is where, sometimes completely relying on a reasoning field may not make sense, because there will be follow-up OMCI flow pushes, as provisioning progresses from the default VLAN, maybe to the any VLAN, to a subscriber VLAN. All of those are ultimately the same task, reporting as the same reason success. The only way you would have to know the difference is if you examine the decomposed flows for that device itself.
Right.
So to make sure that this step is reached, instead of checking the reason, we should really check the flows.
I think both have value. The reason field is very convenient. I will give you that. But really what it means has happened is the flows have been pushed. Now, the difference is the flows showing up in the device might show up before they were successfully pushed. So the OMCI flows push message, the value it has is a message that says the OMCI work is done, right? It finished. It doesn't differentiate between, one VLAN or another. We've talked about making this reason field applicable to a specific port. But yeah, really, this is the last thing that's done to notify the core that we're all done. But again, yeah, it could mean a number of different things depending on if you're pushing an initial VLAN or subscriber VLAN. Even pushing subscriber VLAN results in a tech profile, possibly a tech profile removal, a tech profile re-addition, and then OMCI flows push happening again. There could be 3 reason updates to go with the actual configuration of tech profile and flows. But you just might not see it because it happens so fast.
Yeah, so we may have three different reasons for the new device. There is no guarantee that when it's done, all of them will be in OMCI flow pushed. Is that what they're saying?
Yeah. Yeah, I mean, from time to time, I've seen, like, when testing, like 250, every now and then I'll have one that's last status was tech profile download success, and it didn't show OMCI flows pushed. When I did a disable enable on it, it then showed OMCI flows pushed. So there may be a situation where maybe some out of order messaging happened. But again, it's worth knowing when that does happen.
Okay, I'm going to assign you a task if you can specify what really should we check to make sure that all the news are in the correct state. Like, what are the possible combinations that we can accept, or or what are the states in which we need to make sure the ONUs are not.
Okay. Yeah, and it may be different per workflow. I think that's probably the key.
Okay. Okay, there is another section that is very similar to the one for the AT&T workflow. I still need to compile the same for the Deutsche Telekom and Turk Telekom workflow. So I'll probably present all this section next week. Also because 35 minutes are gone already and we have some more topics that we want to touch.
Matteo, just a question from my side. Would it make sense at a certain point, maybe after we smoothen the process, to create a script to collect as many of these things as possible in the requirements? Because some of these things can be pretty easily achieved with one or two, I don't know, kubectl commands, especially the one that you had up before. Like if you go up like version of the container, things like that, those can probably be easily obtained by a few commands. Would it make sense after we decided that this is actually pretty good and we have all the information we need to script this?
Yeah, absolutely. So we're actually starting in parallel to create a Jenkins job that you can configure and run with a different number of ONUs and different configuration.
Oh, that's great. Perfect. Thanks.
So are we at the point now where we can, with ONOS in place, actually do 250 or so ONUs and configure, bring them all up and configure them within a known period of time? Or that's what this test is all about, and we haven't done it yet?
So the few times I tried with 256 ONUs, I've seen the load in the RW core CPU go up, and in few cases I've seen it restarting. So no, luckily I never made it to 256. I think my best run was up to 205, 206.
Yeah,
Okay.
I was about 200 or so, and 200 was pretty easily done in under 15 minutes, if I believe correctly. It was when we started going over 250 that the core needed a lot of time to do a lot of processing.
And again, all of that was without flows, right?
No, that was with flows. So when I removed flows, from the equation, I'd have to run it again. I seem to recall it was much quicker, but there was a distinction between just adding ports and then adding ports and adding flows at the same time.
Yeah, I think you mentioned last time it was like 2 to 3 minutes for like 250 without basically ONOS, right?
Yeah. It's just getting the ports up. Didn't seem like it was so bad anymore. It was just when the ports or when the flows started being pushed is when things really started to slow down.
Yeah. And maybe that leads into Ken's.
Anyway, so with this kind of reporting, we do have a intern who's now starting up, and he should be able to report numbers that sort of, for at least one kind of measurement. So it should get clear soon over the next couple of weeks.
Yeah, I agree. We need kind of a standard measure. We all kind of have our own anecdotal measure. So, but yeah, this is good.
Do we know when we are going to start this testing officially? The reason I'm saying that is because I have an update that I need to put in the core that requires a library change that Theo is working on. And once that goes in, that will change a little bit the way the core process, because today it's wait for a response from the adapters. to release certain resources in the core. So with the change that I'm doing, it will just send something on Kafka and release the resources, and then wait asynchronously for full response from the adapters.
Yeah, so that's the transaction lifecycle work, right?
Yeah, exactly. Yeah.
So, you know, basically, whenever you're ready, go ahead and push, because one of the things in this reporting mechanism is that you should be able to report, you know, okay, what version of master or what get it batch and master are you testing this on, right? So we can actually, even if we start the measurements now and start reporting it, once your stuff comes in, there should be an appreciable difference, and then we can report that as well. So
okay,
I don't think either work has to be gated by by each other. It's just our intern is almost ready, so let him work on his own pace, and then you go ahead and push, and then we'll measure it and report it with that change in.
Okay, cool. Works for me.
So the sequence of tests that we just kind of went through. So it sounds like basically we're going to discover all the ONUs, however many there may be, wait for them all to get into a position where they're essentially active and have the minimal MIB pushed to them, and then allow progression onto flows. Is that the idea, or that will happen, as each ONU comes up, the flows will get pushed as it would normally.
So in a normal system, yes, as we should start pushing flows as the ONUs come up, right? But right now we're trying to boundary wall it. Okay,
that's a good idea.
How does it behave without? How does it behave with? And so on and so forth, right? So we can learn more about the behavior of the system. But I agree with you. I mean, in a normal in a normal operation, you should really be doing things as soon as things become activated, right?
Yeah, that's the way it would normally work. But at least here you can get an idea of, what kind of thresholds there may be in the system. If everything's active, then I unleash the tidal wave of of flows coming in. What bottlenecks are there? Are you better off pacing it or just at least characterizing the behavior of the system, right? So I think that's a good idea. Okay.
Yeah, and hopefully we'll be able to create this Jenkins job that has just a set of parameters that let you easily configure the kind of test you want to run, so we can run back to back with the flows and without the flows and see how that affects the system.
You're right. And I think Ken had mentioned something about some overhead that's involved in the core with regard to when devices are discovered and their ports are discovered.
Yeah, so that's what the next topic is. It's about core profiling, right? So,
okay.
Yeah. So, Don, do you want to talk about that?
Sure. I would say that there's one thing. So I've been at a conference thing for a few days, so I haven't really made any headway since like maybe last Friday. But other than digging through the code, one thing I can't really get a good picture of yet, and I'm just going to try to figure out if I can do that, is how much time we're spending in a locked state. Does that make? I mean, I can see that locking and unlocking are fairly expensive, and we do that for every time we touch that graph database. What I don't have a picture of is how much time we're spent blocking somebody, trying to access that. But clearly we're bottlenecking on updating that graph database, and you know, so Matt and I've been chatting back and forth quite a bit.
But you do have a picture, right?
wondering,
You have that SVG sort of graph with percentages, yeah.
Yeah, it just doesn't tell me. It's like if you got 15 different Go threads, effectively trying to update that graph database. What I don't really have a good picture of is how long are those other threads spending in a blocked state, or if you know what I'm saying.
Okay, so I understand that what you're saying. I don't. Pretty much like the update of the graph itself, the pure the algorithm to update that is pretty fast, because I just I test them like.
Yeah, but they're still writing it every time to etcd,
yeah.
right?
Yeah.
Unless
so,
I mean, so,
no, it doesn't write it. No, it
look,
doesn't write. It doesn't write the graph to etcd. What where it's the bottleneck comes in is to build the graph, it needs to know the ports that are on the devices. So it needs to go and get the port data. So every time you go and get the port data, if there's some other actions happening on that specific device that has logged that device, then it will have to wait until that log goes away before it's able to get that device information to proceed. So that's getting the device is the one that is, I think, is causing most of the latencies there.
Okay, so I think, Matteo, I think if you scroll, I don't know, Matt, scroll down, there's a box on, it seems like it's on the right, where you can see the locking and unlocking. They're decent size, but, and I don't know if this is really the time to bring this up. Does the graph database actually match the way, I mean, the model for the data itself? And I just say that because if I was doing this from scratch, the data is very relational, right? PON ports belong to an OLT device. ONTs belong to a PON port.
And we have a simple one-level tree, right? Bunch of ONUs connected to an OLT. So do we really need the complexity of a graph or?
Yeah, isn't it kind of predetermined?
We don't need that complex data. Originally, we had that in mind so that anything can be extensible. We can just add any number of devices.
Yeah. So let me finish that thought though, because so relational databases are, they've just been around longer than I have. So they're very optimized, and the reality is, like, when you're getting like flow stats, it really doesn't matter if it's a dirty read. So I think there's just stuff you could get from even whether it's an in-memory relational database that you then cache out every 5 minutes or something. If your flow stats don't update the very latest statistics, it's okay. You're going to pick it up in the next round anyway. So I think that you could actually probably eliminate a great deal of locking, and in a relational database, you can just lock the table you're actually writing to. So I don't know. It's when I was looking through it, just the sheer number of locks that you run into. Now, and I understand. I think we could probably improve some performance by releasing the lock as soon as we're done, not in the deferred state. But really, I'm just wondering. Maybe we should have just a whole meeting to discuss how we manage data, manage in-memory data and persistent data. But it really, in my mind, it really is a good candidate for a relational database.
I think you're saying two different concerns. When you're talking about database, like I was thinking you were talking about the device graph itself, because that doesn't even go to the database, that remain in memory only. Are you talking about any data that is right to the database?
But you're still locking it to update that device graph, right?
Yeah, the device graph, yes, that's the one that I said that it's it needs to go and get the data, the device data, and there's a lock there. Yes, but is the issue that you're seeing limited to the creation of the device graph, or you're seeing it elsewhere, even if there's no creation of the device graph, with the database, writing to the database?
I think maybe we should make the distinction here between the data being operated on in memory versus what's being persisted to etcd.
Well, okay, but forget about even etcd. Just kind of the nature of the graph forces you into some locking that wouldn't actually be necessary in a relational database, right? If I'm adding a port to an OLT, I don't need to lock the OLT. It's just a new write to a table that references the OLT table in a fairly normalized database. And to Saro's point, it's just there's some if you're modeling out a big network and whether it's OSPF or something else, a graph database is perfect for doing that. But this is really hierarchical. It's a tree. It's not a graph per se. Like I said, we could have a longer discussion about it, but I think you could get rid of almost all your locks in the if you used in like an in-memory SQL type database or relational. It wouldn't have to be SQL accessed.
It's some of the logs. For example, if you take the case of you're saying adding a port to an OLT, you don't need a lock on that OLT device. Then what happens if there's two operations trying to add the same ports on the same device? So what you're saying is, instead of doing that in memory, just leave that to a relational database to sort out. Is that my understanding?
Well, yeah, so in a normal course of events, you're not adding and removing ports ever, right? So it's not like a give me everything type of query is likely to contain data that's no longer there, right? The ports aren't going to come and go. I don't think that just looking at the nature of the data we're dealing with, it's almost all additive.
And again, the word relational database doesn't necessarily mean committed to disk, right? This can all be done in memory.
No.
Regardless.
So I don't know. Like I said, I think maybe that's a bigger conversation that we don't have adequate time to dive into. But
I think it's worth a discussion. But definitely, it's a bigger conversation because the whole data model is based on storing a proto definition in the database, and then every time we read it in memory, we need to make a reflect on it to figure out what kind of type it is. If we go away from that model, then definitely there's a lot of improvements that can be done in terms of latencies there.
Yes.
Well, just it is looking at the visualization here, it looks like a lot of time is spent, marshaling and unmarshaling protos, presumably from etcd, if I'm reading this right.
Correct.
Just to make sure,
maybe
the thing is, most of the processing, etcd will literally be a write thing. we're writing to etcd. Most of the read and everything is happening in memory. So I'm just wondering, this graph that you have here, is it, what kind of action was happening on the system?
This was, so I took a snapshot in the middle of BBSim. I think I was like 64. I forget what it's in my original post, but just I configured BBSim with a lot of stuff, right? Because when you're doing a profiling, you want it to break and you want to know where it breaks.
I think it was a 16 by 16 topology, so 256.
Yeah, that's it, 16 by 16, right? So just in the middle of BBSim thrashing and everything else, I just took a 60-second snapshot right in the middle of the whole process just to see. Again, when you're profiling, you really want to push it to the point where it breaks so you can actually see where you're bottlenecking. And, it's running on my little laptop with 6 core and I think 32 gig of RAM. And I'm, running a GUI, everything else. But, it's just in the middle of, it's maybe like if you started up a whole system with Docker Compose, with BBSim and everything else, and, so it's running, and then you add the OLT to Voltha, wait like 2 minutes, and then take a 60-second snapshot. That is what that graph, that visual graph represents.
Mm-hmm.
And you had loaded templates for BBSim, right?
What do you mean by templates?
So there's a shell script where you can load in etcd the template for the BBSim ONU, so it doesn't have to spend time walking the MIB for all 200 of them. Because there's the first at least 4 or 5 minutes.
Whatever that YAML file that you gave me to do the BBSim scaling test, that's what I did. I didn't.
Okay. So then we may have to run it again because by default, it will not load templates. And the templates will cut at least 4 or 5 minutes off of the initial startup time.
Okay. Well, that might be a valuable snapshot as well.
But again, the big spin here, kind of just background for Ken, because he probably wasn't, I don't think he was here last week, is after the MIB templates have done their work and the ports are added in the core and in ONOS, there was, at least in my estimation, when the flows started getting pushed is when we had minutes of time, I'd say 10 or 15 minutes of core using, I'd say 10 CPUs worth of processing, 1,000% of CPU. And all of this was during flow processing. So we'd gotten past, in my estimation, most of the port work and was now just processing flows. So I think we should run this again when we know we're processing flows just to see where we're hitting bottlenecks there.
Yeah, so maybe.
And again, if you're running profiler, maybe do it without the flows also.
I'm sorry, Ken, what did you just say?
This was taken from a fairly recent build, right? Like,
last week, masters from last week.
Okay. Okay. And how many cores are we running on this machine?
This is my laptop with 6 cores.
Okay. Because the writing, because in the core there's different routines that take care of writing to the data, to the KV store, and other set of routines that take care of processing things. And since every data is in memory, every time you're doing a processing, you change something, you send it to the part of the routine that is going to update the KV, it's done, and keep going. So I'm just wondering if there's something there that definitely, I'm looking at the numbers like definitely point to some, the marshalling and then marshalling and writing to the KV. with Proto seems to be quite intensive.
Yeah, and this is why I think I want to go back to and do, like we said, compartmentalize the actions and then profile it while only one thing is going on. And then we can kind of get a sense for, is it flow decomposition, working with the graph during flow decomposition, or is it working with the graph while adding ports? Because when we're trying to do both at the same time, it all starts to run together. And I know when we do both at the same time, it's very costly.
But I mean, so some of the stuff Matt and I talked about last week, or actually probably early this week, was, move BBSim off onto its own thing so its thrashing doesn't actually steal cycles. I mean, I think this was a kind of a first draft look at where we're at, get us, looking at the right direction. But I think there's probably significantly more testing to do before we're ready to say, okay, well, this is the approach we should take.
And I think Mateo's baseline test plan, maybe that should be another point, is where BBSim is running versus where the Kubernetes cluster and components are running.
Yeah, that's a good point. So far in my testing, when I tried running BBSim on the same system or on a different machine, I haven't seen meaningful difference, but that definitely is something we need to specify in our test.
Yeah, I concur. In my testing, in the kind of stack of busiest processes, BBSim was near the bottom, OpenOLT was near the bottom, OF agent was in the middle, then ONU was about, you could say, 20 to 50% when it was settled down, but then the core was like 1,000%. It was off the charts. But again, it's worth baselining where everything's running so we all have the same sort of environment to test against.
Right.
Yeah, that's good info, Don. The one that you have here, it's quite interesting.
So yeah, if the profiling is built in and can be run based on a flag, I do believe, Don, that you can then just access it via a web service running on the process itself. So you could actually pull up a browser and see this, right?
Yeah. Well, okay, you can't see this exactly from a browser, but you can see, there's a lot you can see from a browser. This is, I mean, it's pretty straightforward. I think if you scroll down, oh, no, it's not in there, but you can do just like go tool pprof web, I think is all you do, and that'll generate this SVG.
I see, okay.
In fact, yeah, that has some of the stuff in there. That's not me, I don't like cats.
That's clearly Zach.
I got a dog that does that kind of crap, but yeah, and I'd say give me like a couple days to like maybe middle of next. Well, how about by next Friday? I'll come with much better data, much more actionable data.
Sounds good.
So I'm going to have to drop. I've got somebody swinging by. See you guys.
Okay, since we are at the, bye Don, thanks. Since we are at the top of the hour, is there something urgent that we need to discuss? Otherwise, I'm going to move the remaining topic to next week.
Matteo, just a small update on IGMP.
Yeah, I've seen your message on Slack.
Yeah, okay.
I'll review the patch today.
Yep.
And on the same line, Pragi, I'll double check the comments I left on your Jira item, and I'll make some testing to make sure everything is working, and then I'll reapply your patch.
Yeah. Matthew, I was expecting maybe you might be facing some issue because now are having delay in sending discovery indication.
I couldn't hear you very well, but we can chat offline if that works for you.
Hello, can you hear me?
Pragi, you're breaking up a lot. I cannot understand what you're saying. Okay, guys, thank you very much for your time. Have a good weekend, everyone, and talk to you next week.
Thanks, you too.
Take care. Ciao, Matteo.
Bye, guys.
Bye. Thank you.